we're going to go over how to apply density to gas stoichiometry problems using the ideal gas law. We're going to first begin by using the fact that moles is equal to mass over molar mass. Or I could just abbreviate this as m over molar mass. Now I'm going to use this fact to get density in PV is equal to nRT. Density is equal to, it's normally done in grams per liter for things that are very small, but it can be anything. So it's just mass over volume. It's usually, for the purposes of this class, dealing with things that are going to tend to be small. It's going to be grams per liter. So what I'm going to do is take n and substitute m over molar mass into this equation. So this would be m times r times t over molar mass. And now to get density, which is mass over liters, or volume, really should just be more accurately described as just mass over volume. I just say liters because I'm just so accustomed to using grams per liter in everything that I've ever done. But I'm sure on an industrial scale, or just a different field, it would be done in something else. But mass over volume, and here I can see that I can get a mass over volume. If I were to divide both sides of these equations by V, I would end up with P on this side, and then mass times R times T over molar mass times V. So I'll do that. And density is defined as mass over volume. I have mass over volume here, so what I can do is replace m over v, factor this out, and replace that with d. So this becomes P is equal to d times RT, where d is density, over molar mass. And sometimes I'll see this written as molar mass is equal to dRT over P. It doesn't really matter what it's in. The whole point is to know the substitution, because in many different equations, this sort of density substitution or something similar will be able to be made. So that's it. That's how to apply density. I'm not going to go over examples. This is really easy. And this is just an idea. This is how to manipulate equations to get something different. In this case, it happened to be density, but if I wanted something else, and it doesn't necessarily have to be PV equals nRT, there are going to be all kinds of equations in chemistry and physics where if I want to get something else, what I can do is just manipulate the formula to equal like something like density, so I can substitute it in, so I can make a substitution. So that's what really I wanted to get across with this example, just the idea of substituting to make use of information that is not readily apparent in the initial way that the formula is presented.